webinar is going to be on CADnet, which is a brand new module inside of CARLSON Civil Suite and Takeoff R6. And hopefully everybody can hear me. I don't want to be too loud or too quiet, so I'll let my sister Karen Cummings is going to be monitoring the webinar, and if we're having any difficulties, she'll let us know. Okay, I guess we'll wait a couple minutes to let everybody get on to the meeting. Here, let me go to the next slide. What's brand new in Takeoff R6 and Civil Suite? There are 3 new modules in Takeoff R6 and Civil Suite. You have CADnet, Geotech, and Trenching. This webinar obviously is going to be on CADnet. There are 3 platforms that CADnet or CARLSON software works on. Those platforms are the AutoCAD OEM, the IntelliCAD 7.2, and the AutoCAD 2014. I have them loaded down here. If I load up the OEM, you can see that this is the Takeoff OEM version of CADnet, and the 2 drop-downs that are specific to CADnet are Digitize and Raster. And over in File, we have Import Export, and we have Import PDF, which is critical. I'll be showing that later. The BIM, the CADnet product is also in CARLSON IntelliCAD and the suite of software of CARLSON Civil 2014, and you can see that we have these menus loaded here. I'm actually going to switch to the CADnet menu there, and now I'm in IntelliCAD, and there's the Digitize Raster, and we have a PDF drop-down in the IntelliCAD version and the BIM version. And the third platform that we have is in AutoCAD, and you can see that I'm in AutoCAD right now. I have the Digitize drop-down, the Raster drop-down, the PDF drop-down, and the BIM drop-down. So those are the 3 platforms that you can purchase CADnet to work in. CARLSON Takeoff R6, I showed you, is our embedded AutoCAD product, and that comes with AutoCAD. That's $9,000. The Takeoff R6, let's just go through this real quick, or construction add-on modules for IntelliCAD and AutoCAD also can have a breakdown of these modules, CADnet, Geotech, and Trenching. There's the prices. And the Takeoff R6 suite, above 4 modules, are all in Takeoff for inside of AutoCAD or IntelliCAD for $7,500. Okay, Takeoff R6 2014 overview platforms. I've already mentioned those. We have the CADnet works in 3 CAD platforms. I've shown that to you. And you can also customize the Takeoff R6 or CARLSON Civil Suite toolbars to add and remove icons, and specifically add the CADnet icon toolbars. And I was just going to briefly show you that right now. And first, what I want to show you is in the settings drop-down that you can load the CARLSON menus by selecting settings and then going over here and coming down and selecting CADnet. Now I'm already in the CADnet menu. That's one way to load it. The other thing that I want to show you is these toolbars right now. If I move my cursor up here, leave the cursor there for a little while, it says Raster Edit. And if I go to Raster right there, you can see all the menu items on the icons on the left are going to be icons in toolbars. And If I drag this one out, you can see that here is a command raster nearest snap. That is in the raster drop down right here, raster nearest snap. And if I close this guy, hit the right key right here, I can scroll down and you can see there's raster edit. I can turn it back on again, and then I can just grab the left side right there and just drag it and drop it. And that's how you can load up the raster icons or toolbars. And I'll just go through the two menus that are in CADnet that have most of the toolbars. This is digitize. This is for digitizing both on a digitizer or heads-up digitizing on screen, which I'll demonstrate later. The other toolbars are in the raster dropdown right here, and we do have PDF, import PDF, and BIM has no toolbars. So that is how to load up the CADnet toolbars. The CADnet new menu consists, you can load it in these two fashions as I explained here. You can select it from settings and go to the CARLSON menus and select CAD menu, or you can go up to the toolbar, which is right here, and select it right there. There are four key CADnet drop-down menus: digitize, raster, PDF, and BIM. The first drop-down, PDF drop-down menu, the command that's very important to CADnet, allows you to use Adobe PDF or any PDF files and insert them as either line work, as individual images or range of images, and if you do save to file, save to image down here, it will grab the PDF file, and if there is like 17 pages in the PDF file, it will bring in all the PDF files as images, and it stores them as TIFF files. And let's go ahead and demonstrate this with a cross-section sheet at this point. So I'm going to just go up here to File and do New. Let's set it to 20 scale. I have a directory right here called cross-section PDF, and we'll just call this cross-section 1. Okay, at this time, let's go up to PDF and do import PDF. And the cross-section file that I want to grab is this one right there. Pick it and pick open. And we want to do insert as image. And I want to bring in one page. And I'm going to pick this, I'll call it page 10 or whatever you want to call it. And now it comes up and says page 1 to 99. It's just defaulting. If you want to actually see how many pages are in this PDF file, you can do scan file or scan PDF file, and there are 17 pages. Obviously, you can load up this this cross-section file and take a look at it just in Windows. And if I type in 10, hit enter, you can see this is the sheet that I'm going to bring in. That's sheet number 10. Okay, so to bring in just sheet number 10, I'm going to go to page 10 here. And I could bring in a range of pages or sheets, but I'm just going to bring in one sheet. Click OK. And it is monochrome. And down below in the lower left it says pick point to insert raster. And I pick this and it says scale. I'll just hit enter. Rotation angle, I'll hit enter, and it brings in that one sheet PDF. And if I go to the directory right there, it actually created a page-10.tif file or TIFF file. So that is the file that it created from the PDF file. Now at this point, before I do the plan view, let's just take time to digitize these cross sections and calculate end areas on maybe 2 of these sections. If we go back to the digitize drop-down menu here, we have tablet, and this is for paper digitizing. This is for just standard digitizing like you normally would do with a digitizer. In this day and age, with so many PDF files and electronic files being sent back and forth, digitizing, or what is called heads-up digitizing, is much more common now. And that's what I was going to show you, is that even though this digitize menu works with a digitizer, if you go to the digitizer settings here, and it says use mouse, if you toggle this on, it will allow you to use the mouse to digitize on screen from the PDF files that you've brought in, converted to a TIFF file. So at this point, I'm going to pick OK and say use mouse. And we're going to go up to digitize, and we're going to come down to cross sections or sections. And it comes up with this pop-up box, and we're going to create a new section file. And I'll do specify section file to digitize to, and I'll just call this EX1. And you can digitize a second file, and I'll call this FX1. And you can do up to a third, fourth, and fifth cross-section file. So if you have multiple subbases, you can actually digitize them and get your end area volumes. And that method right here, it says station interval is 25. That is correct. We're going to pick OK. And now it says section station to digitize. And you just scroll up, and it's 1075. First section point, and we'll just pick right there, enter offset, and scroll up, and that was 55, and that is 365 for elevation. Second point, and here I'm going to -5 is the offset, and that is 360. And we need a third point. And why we do 3 points is so we can, that's -75, so I type in -75, and that's going to be 370. And the reason why we do 3 points is that it allows us to bring in the raster PDF file, and it doesn't matter what rotation it is. If it's slightly skewed, it doesn't matter. If you digitize accurately 3 points on your cross-section, when you align it, you're ready to now digitize. So right now down here it says digitize breakpoint for existing one at 1075. So we'll just start all the way over here. And up here. Looks like a breakpoint right about there. Right about there. And vertical saturation as I'm digitizing, it's on the extreme side. So I'm going to hit enter, and just move this guy down, window up a little bit. Notice it says digitize breakpoint for FX1. That is our final cross-section file. So I'm going to start right there. And I like to, when I do the subbase here, I'm going to go a little bit to the right of where I picked. I'm going to pick on the left side, right about there. Come down right about there. And right there. And we'll just pop out here. Just normal digitizing here. Hit enter, and it says digitize next station. Let's digitize one more just to show you the sequence here. So I hit enter for 1100, and at this point it says select reference point, and we'll just pick here at 370 and 5. I pick there, I'll type in 5 for the offset and 370. And notice I don't have to select 2 more points. It automatically knows that we're on this section and we're doing a second section. So at this point it wants to have me select the existing. I'll just pick here. And one thing about showing CADnet is it is about digitizing, so I apologize if it seems a little slow, but that is the nature of digitizing, either on a digitizer or on screen. Okay, now I hit enter, and it goes to FX. It says digitize the final, and I'm just going to pick right here, pick right there, come a little bit to the right there. And you could obviously zoom up and be as accurate as you want to be. And if I drag this guy up, you can see that it's vertically exaggerated. But there is the station there. And now I just come down here and hit N. And it says, do you want to do another one? And I'm going to type E to exit. So we created 2 sections from this heads-up digitizing session. To actually check what the cross-sections look like and do end area volumes, I have to switch to the civil menu and go to sections. And first, before I do calculate section volumes, I'm going to go to input edit section file and just take a look at those at EX1 and FX1 files. So I grab EX1 and the reference file will be FX1. And we'll just double pick there. And there is the first section. And if I do next, there's the second section. And I'll do exit, and we'll just do a quick calculate volumes, section volumes that is, and existing EX1 and FX1. And we come up with about 71 cubic yards of cut, which makes total sense on those 2 sections. Okay, at this point, we digitized, heads-up digitizing sections to get end area volumes. But if we wanted to actually digitize polylines for the existing and the final and have them as a backup or a check, we're going to have to redigitize these and scale this raster image. And I went back to CADnet, and before I go into CADnet, I'm just going to type I for inverse or DIS for distance in AutoCAD, and I just want to see what 5 feet was on this guy right there. If I pick right there, and pick right there, you can see that it comes up and says it's 295 feet. So we got accurate end area volumes by calibrating with 3 pick points on the first section, and then we only had to pick on the second section or any other section on the same sheet. We only have to pick once and tell it the offset and elevation. Here, I want to actually digitize to scale this sheet right here. To do that, I'm going to go to the Edit drop-down and come down to Scale here and do Scale Wizard. And right here, I could just type in, if I knew the scale, I could type in the scale, but I don't know what scale I brought this drawing in on. So I'm going to pick a distance on the sheet and tell it what the distance is, and it will calculate what this scale should be in there. So I go to Screen Pick, and you can see that this is -75, and over here is 75. And it says, what is that distance? Well, it's 150 feet. I pick OK. And it comes up, that's the scale factor it needs. I pick OK, and I'll just type ZE for zoom extents. And now let's check the distance between any of these. I'll just do I for inverse or D for distance. And you can see that, well, 4.96, but you can see it's very close to 5 feet there. And at this point, we're back in CADnet, and all because of digitizer settings, use mouth is selected, we can actually digitize this sheet on screen. And at this point, I want to just go to digitize, and these options here allow you to select if you're digitizing the existing or the design proposed. So I'm going to select existing here. I'll do it again. And it says set digitizer underscore exist, digitizer target set to existing surface. And at this point, I'm going to come down, and because these are not contours, I'm just going to do 2D polyline. And it defaults to existing, and we'll just pick OK. And at this point, just like you would normally do with a digitizer, except you're doing it on screen. And the advantage of it is that if you really want to zoom up, you can. Can't do that with a digitizer. And like I made a mistake there, I'll type U for undo. I didn't want to make a critical mistake. Come up here and pick that, and that's as far as I need to go there. And it says, do you want to do another one? I'll say no. And we'll hit escape, and now I'm going to do the final. So I go back to digitize, select design surface, and go back to the 2D polyline command. No, it says final this time. Click OK, and because this is CAD, I can just type nearest because there's an actual entity there. Pick that. I'll go down a little bit to the left, pick on this side, and you can see I digitize a little bit to the left. As I'm going left or right, I keep digitizing a little bit, making sure everything is left to right. And we'll come up here. Type NEA for nearest. And digitize that, and we'll do one more section. And I'll just go to digitize, to existing surface, and come down to 2D polyline. Okay, that's as far as we need to go for the existing. Now, at this time, I wanted to kind of show you that the digitizing drop-down menu allows you to do heads-up digitizing. And if I go to the raster drop-down, I can actually do set raster image. Come over here. You have to pick the edge of the raster image. That sets it as the current raster image to use. And though I prefer to digitize using the digitize drop-down and manually digitize, we can go to the raster drop-down here and do trace polyline. And I'm going to go to final. Segment file, okay, put it right there. All right, let me do NEA for nearest. See if I can grab that there. Then I'll grab here and grab here. And you can see that I don't have quite the control of manually picking this, but as I'm picking, it drags along there and traces this, and you can see that when it runs into an intersection, it tries to stop and let you pick where you want to pick. Okay, hit enter, and little fix there. And you can see why I kind of like to manually digitize. And you can see it created a lot of additional points. And I'm just going to go to polyline utilities, reduce polyline vertices, and hit return for point 1 and select this guy right there. And there was 53 vertices created, we moved 43. So now the problem is we do have moved 1 right there. Anyway, you get the idea. So that's why I prefer to digitize with the digitize dropdown and manually digitize my cross sections. Now, the raster snap option does have an option where I could type M for manual and digitize manually. Let me show you that real quick, being that this is a CADnet demonstration. I'll do trace polyline again. We'll do final, and I'll just pick right there. And now if I type M for manual, I can pick right here and pick right there. If I want to go up and do snap to raster snap, I can pick right there, and it will make sure that I snap to it. And if I type enter, it goes back to allowing me to just automatically let it trace until it finds an intersection, and just keep picking those intersections, and you get the idea. So you can draw. Now that one worked out real well. I picked that guy right there. That's not too many vertices. And it essentially traced along the raster image and created the vertices. But you can manually select and or snap to the raster line if you want to, using the raster drop down there, trace polyline and raster near snap. Okay, now that I have these two drawn and I want to do the same end area volumes I did before, I have to go back to the civil menu and go to sections and create sections from polylines on section grids. Pick that, and this is going to be 5 and 5 for horizontal and vertical scale. It is 25 station interval, and we're going to do new, and I'm just going to call this EX2, and we're going to specify a second file, and that's going to be FX2. Now pick OK, and it says station is 1075, and the elevation is 365, we'll call it. And it says intersection on, pick point at starting elevation and 0 offset. So I come back here, pick that point there. Now it says pick the existing polyline, I pick that guy. Pick the final polyline, pick that. Then it says next station is 1100, that's correct, I hit enter. And it says 365 is here, and it says pick where 0 is and 365. I hit return for 365 and pick right where 0 is. And it says pick the existing polyline, and I pick here. And it says pick the final, and I'll pick the bottom one for the subgrade. And it says next station 1125. I just type E to exit. And just like I did before, where I digitized without creating entities, this time I created entities so I can recreate this relatively quickly. Go to those two, pick there, and there's that first one that I did. And that was done from polylines at the real scale of the drawing. Hit OK, and we'll just do a quick, see if we get 72 cubic yards of end area volumes, and that's EX, that's FX, pick OK, and we're looking at 61, 72, and 61 cubic yards. That's actually what I got when I did my testing beforehand, was around 61, 62 cubic yards. So I pick exit, and that pretty much ends my example for working in cross-section data. Let's go back to the PowerPoint and continue on. So the PDF drop-down, we use that to insert an image to then digitize. And the menu item, as you can see, has convert polylines to text and convert dashes to polylines. You can use that raster snap to draw in the dashes and then use this command, convert dashes to polylines, to essentially convert it into one polyline or a dash polyline. Let's go to the next menu, digitize drop-down menu. Tablet for traditional paper digitizing with digitizer board, so you can still do your paper digitizing with your digitizer. The digitizer settings, as I noted here, use mouse, heads up on screen digitizing. You can toggle on mouse for heads up on screen digitizing. I did sections and showed you digitizing sections in 2 different methods, and I showed you the scale wizard to scale the actual raster image to scale. Okay, then I want to talk about the raster drop-down menu and demonstrate this. You have import PDF file, so you always have to import a PDF file and turn it to a raster image, or if you have a raster image, bring it in using draw raster image. What I want to do in this case is do a plan view digitize, where I actually import a PDF file and create 2 TIFF files for 2 pages that I want to merge together. And I'm going to show you that next. So we're going to go up to File, and I'm going to do Open. And we're going to drag this over. That's not the one. That's the one. Okay. If I go to Layer Control, go up to Layer Control Manager, Phase 1, do Restore. Okay, this is my site right now, and I want to bring in, these are PDF file locations right here for Phase 1, and I want to bring in these 2 sheets. To do that, I'll go to the CADnet menu. So I pick CADnet, and I pick PDF, Import PDF file, and this is the file that I want to grab. That's the PDF file. Pick Open, and if I go down here and bring it up, I just want to show you that there's sheet number 47, and if I go to the next one, 48, you can see it goes to down here. That's 48. And I want to digitize this temporary detention pond from this PDF file and insert it into my existing proposed contours. So these 2 sheets, 48 and 47, I want to bring in. So we're going to go to, again, if I do save to image, it brings in all the PDF files, and there's 77 in that PDF file as individual TIFF files. If you just want to bring in 1 or 2, you can go to Insert as Image. And you can see I've already done it right there. And I'm just going to call this 47. I'll just say this is plan view. And I'll just say 1. And I'm just going to go up here. I know which ones I want to grab, so I'm not going to tell it to scan. 47 and 48. All right, and just pick OK. And they're monochrome. Okay, it says pick point to insert raster. So I just pick right there and scale 1. Rotation angle, I'll just turn 1/4 of 1 and pick it right there. And it brings in these 2 PDF files. But and I'll just type in 2000. Oops. All right, I'll just zoom out. Now, here's what I want to do is that here's the top one, so here's the bottom one, here's the top one, and I want to merge these 2 and bring them both in and plot them in there. So what I want to do is delete these two, or I could just type an image and grab that one and grab this one and hit return and do detach. Detach. Okay, I detached it. Okay, now let's merge these. So I'm going to go to the raster dropdown, and this is a real handy command. I'm going to go to merge raster files. I'm going to do select left image, and I'm going to pick that one there. And I'm going to do select right image. That's this one down there. And let's zoom up so we can see this. I'm going to come down here, and I'm going to zoom up here. And notice that we have this building here, that little option here, and that's at the bottom. You can see it's at the bottom of this PDF file, this sheet, and the lower one, it's at the top, and I want to merge these two PDF files. So we have pick control point 1. So I pick this guy, pick right there. I could maybe pick over here. I could try to do a better job and zoom up on it. Okay, better. And then I'm going to do pick control point here, and just pick it here. That's a little off. I'm going to pick control point, pick it over here, and pick it again. Right there. That's up. This is just a presentation. Okay, I'm going to scroll all the way over, and there's the other point that I want to use, and I'm going to scroll all the way over on this one, and there's that point. And we're going to do pick control point 2. And I come up here, and I pick there, and pick control point 2, pick right about there, and now here's the button that allows you to merge these two PDF files. And when you do that, it merges the two, and then it prompts you to save it as a new TIFF file. Okay, and this may take a little while.
Jim?
Yes.
While you're doing that, you have a question here. It is, the last PDF looked like it was created from a CAD drawing. If so, bringing it into ACAD as an XREF PDF, I could snap to the endpoints of the line. And then they said, last part of the comments should have read, then why do you bring it in as an images?
Working with a lot of construction firms, I've heard from them that they ask to get the PDF files, or the drawings, I should say, from the engineering offices, and very often, especially for bidding processes, bidding purposes, they don't get the drawings, they get the PDF files, and the PDF files are not made in AutoCAD, or they're made in AutoCAD in such a way that none of the layering comes across. And the person who's asking the question is absolutely correct. If, first of all, you would ask for the drawing, but if you can't get the drawing, you get the PDF file. If these drawings are coming from AutoCAD, if you go to the file plot command in AutoCAD and save the plot as a PDF file, if you have Adobe loaded on your computer, it will store all the layers and all the line work in the PDF file, so that when you insert it with our command, insert PDF, you can use line work, and it will actually create the line work right from the PDF file, which is extremely handy. And you're right, you could then go right to doing sections polylines to the cross sections and skipping the step of digitizing. So I'm kind of curious why it's taking so long here. And
you have another question here too. Is
okay.
CADnet backward compatible with older CARLSON software such as Survey 212, 211, etc.?
That question I can answer is a no. It is not backward compatible. This CARLSON CADnet new module and the 3 new modules, even though trenching, geotech, and CADnet in some fashion existed in 2013 and previous versions, the current version, 2014, that came out with CADnet, geotech, and trenching, those menus have been all updated so that they are no longer able, you can't bring up trenching or CADnet or geotech in any version by 2014. Okay, we have the merged file here, and thank you for those questions. I was waiting for it to get to that point. What I'd like to do is I'd like to scroll down to see where that little building was. Okay, that's where the building was. And if I drag this over here, and I can see that I have a few issues right here. One little issue right there, but they look like they're pretty much merged correctly. So I'm getting feedback. That's interesting. Okay, I'm going to save this image at this point. Do save image, and I'm going to go down and go to the not the cross section, sorry, to plan view. I hope people aren't hearing that feedback. And right now, I'm not going to store it as a bitmap. I'm going to keep it as a TIFF file. And we're going to do combined. And I'll call this 2 just to keep track of it as I did it once before. And we're going to do exit. And we have completed merging the 2 files. At this point, we want to go up to the raster dropdown and do draw raster image. So I select this, and there is combine 2. Pick open. And I have specify on screen, specify scale, and specify on screen for rotation. So I pick this, and I'll pick right about there. And it says scale. I'll scale it up so it looks pretty close. And then rotation, I've already thrown on. I'll just pick right there. Okay, and there is the merged image, and there's the area that I want to digitize for the pond. Well, instead of doing what we did before, and that is scale and use the scale wizard, this time I want to use align and use the CARLSON 2D align command. This command, unlike AutoCAD align, which is below it, only works in 2D, northing and easting, and well, even if you pick something that has a Z, it will only use the northing and easting and set everything to 0. So you don't get elements or raster images that are coplanar to the axis of the XY. So at this point, I'm going to pick 2D align. Oh, well, I have to do this. I'm going to window up. Here I'm going to do layer off and just freeze my existing. And I'm going to draw a polyline. I'm going to do 2DP. And let's just call this digitize right there. And let's grab this one right there, turn the ortho off. Let's go look for that in this drawing right here. And that is, I have to digitize 2 node points that are in my CAD drawing that also exist in my raster image. So I hit that one, hit return, and we'll do another one. And I'll grab this guy right here. Should be able to see that. Yeah, there you go. And we'll just grab this point right there. Okay, and I'll hit return. And if I go to the layer control command, quite a few layers in here, but I put this in the digitized layer, so I'll just type D. There we go. And just change the color to magenta. Okay, so at this point, I am ready to go to the Edit dropdown and select Align, 2D Align. So it says select objects to align, and I only want to grab this one raster image. So you grab the outside polyline, and that's the entire image. Hit return. Then it says source point, and I'm going to grab that point. And then it says destination first point. I pick that. Source point, pick that one. Destination, that one. And it says scale object. Absolutely yes. And there you go. And at this point, I'm going to just type E for race, get rid of my lines. And at this point, we need to go to the view dropdown and go to display order and do send to back so that we can get the line work plotting on top of the raster image. So I pick there. Now it's on top. And what we want to do is just look at the contours. They look good enough for what we have there. And okay, at this point, that you can see, let's go back to the PowerPoint and just kind of recap what I just did there. We had raster dropdown, we imported the 2 PDF files and converted them to 2 TIFF files. We then merged the 2 raster images. We then drew that one raster image, and I haven't set it yet. To do heads up digitizing, we have, and then I did 2D align, and then I did send to back. And the next thing I want to do is digitize the interior pond, but I would prefer, here I want to go to quick view.
So Jim, you have several questions here.
Sure.
Let's see, because raster images become so heavy in CAD, would it not be easier to open the merged image into a new drawing? Whoops. Oops, I lost the question.
Oh.
Then trace into a new drawing, trace over, then insert the results.
You still have to align the raster image to the coordinate system that the drawing's in. It just so happens that this drawing, I know, is in Pennsylvania South. It's actually in State Plane. So that 2D align operation, and these, this is a new laptop, but bringing in these PDF files is really small. So I don't think that these raster images are taking up much space in the drawing. If I go to XREF here, let me go to plan view and just see what size they are. If I combine 2, it's about 4 or 5 meg. But as you can see, I'm painting around and it's regenerating very quickly. To me, this is how I do it. So I've never had a problem with PDF files being converted to TIFF files and then bringing in TIFF files. And I very often will save them as PNG files. But TIFF files and PNG files seem to be relatively small. PNG files are smaller, so I usually use PNG files. At this point, I want to just you have another question, Karen?
Oh yeah, there's a couple more. When digitizing cross sections, can you use typical sections to automate the digitizing process?
Say that again?
When digitizing cross sections, can you use typical sections to automate the digitizing process?
Yes, if you drew a polyline that's going to be reused over and over again, you could just you could just use CAD and then copy and paste it to additional. The existing, I would think, would undulate and change for every section. But yes, you could do that. My experience, though, especially with that job I brought up, was a DOT job, is every section was, virtually every template final proposed cross-section was slightly different on every section. But you could, yes, if they were the same.
And then, okay, Then using a TIFF creates less of a drag. Nice. I know large PDF files slow things down. That was just a comment. And then someone else asked, can this merge function be used if the drawing is a PDF vector drawing?
Actually, then you would just, I don't have time to demonstrate it, but under import PDF right there, I'll grab this guy. And if I did insert line work, and I know this PDF won't work because it wasn't created in AutoCAD and have the layers in there, but you could bring them in using this command and it would convert it back to an AutoCAD drawing, and then you could just use basic AutoCAD to essentially join different plan views together. So the answer is yes on that last one. If the PDF files are effective.
One last question. When digitizing existing contours, can you window and have all the existing contours digitized at once, or do you have to trace individual contours?
That's a good question. The trace polyline command only allows me to digitize one at a time, and I have to, actually that's a question that it's possible. I haven't asked that, and I've always traced them manually one at a time. But I'll have to actually refer back to Todd CARLSON. Whoever that is, I'll see from Todd, who's the head of the takeoff product. I'll find out if there's a command, or if this command can be used to do multiple polylines. I've only used it to do one polyline at a time. Okay, let me digitize this one polyline here just to show you how this is done. I'm going to go back to raster. I'm going to do set raster image, which I probably have already done. I do that, you can see image selected. I've already gone in here before the webinar and digitized everything but the bottom existing contour there. And I'm going to do, first I'm going to do this, contour polyline, but I'm going to set it to the design surface and then come up to digitize and do contour polyline. And final contour is actually the layer that it's in. I'm going to pick OK. And it says 326, and it's actually 325. If I hit the B key, it goes to 325. If I type A, it goes, A goes down, A down. If I do B again, it goes up. If I do A, it'll go back. So you can actually use the digitizer, A or B key, or you can just use the key, which I just did there. So I'm going to hit enter for 325. And it says first pick point, and I'm just going to pick a point here. And this is the last thing I'm going to do for my presentation, and I'm going to, hopefully I have, for undo, I've got the snaps on right here, so I'm going to watch out. Just go here. Just do see close. Okay. Now, if I hit escape to exit out of there, let's just go to settings here, inquiry, drawing inspector. Make sure that I put that in the final contour, and that's in 329, that's 325, and that is correct. And at this point, I want to go to the civil package and check the volumes on this. And I go to CADnet, define layer surface subgrade, that's my existing. These are my final. Everything else is in the other category. Save that, and I'll just come up to CADnet and do make design surface, and it's done. And now I can come down here and do calculate total volumes. Update the existing though, and pick OK. And there's I have a little boundary polyline around the area that I digitize, and you can see it comes up and tells me what the fill volume would be in that location. And the last thing I wanted to show you is that from that digitizing, you can go down here and do quick profile. And well, it's really hard for me to see yellow there, but if you can all see the proposed is yellow, there's a berm that I digitized in there, and we digitized in the low point for the pond right there, and I guess I can draw it so everybody can see it a little bit better.
All right, well, we're in CARLSON Software 2014. I have a surface here built by contours. I did go ahead and make the surface ahead of time. And so if I bring in the tin triangles, you should see them import on top. And this might help me review my surface. And so we have a surface for proposed ground here. And one of the things that came to our attention is that the architect has a Revit model or a BIM model, and we'd like to see if their model meshes in with our terrain. So we're going to use some of the new software that's in the 2014 CARLSON CADnet, and under the BIM category, we're going to import the BIM model into the CARLSON design. You'll see the building outline just came in, and it's importing the objects now. This is supported by the IFC file type, which all the BIM softwares can create. IFC is the Industry Foundation Classes, where everything in a building has been classified based on a standard that was developed, I understand, by Autodesk somewhere in the mid-90s as they were getting into the BIM world. So not only when you bring in this model are you getting a 3D object, but you're also getting the intelligence behind those objects. There might be desks and chairs in here, windows, doors, there could be utilities and piping. And so the idea would be maybe to check your design, and if you have a water line coming into the building on, say, the east side, then there should be a tap on the building to accept that. And it looks like it's almost done with the import. All right. And it looks like it's in now. And what I'm going to do is use a CARLSON tool here under View. We're going to use the 3D Viewer window and see if we can inspect the model along with our terrain. Now this viewer in 2014, it's purported to be some 300% quicker than it was in the past. And right there's your view on a standard laptop. If I had tried to use 3D Orbit in AutoCAD, we'd probably still be sitting here. So the viewer in CARLSON is excellent. Now you'll see the BIM model and my terrain model, and I can see them together, and I can see how they fit. There's a landscape berm in the front of the building. We have detention ponds off in the south, and there's the building itself. I have it colored, which we don't need to do. And so there's your BIM model integrated with the CARLSON data. Okay, and I can see some of our modeling needs to be cleaned up a little bit. There's a little overlap around the sidewalk. Maybe it's intentional, maybe not, but I can visually see that right now. And so that's the idea. I'm doing quality control. When it comes to BIM, this is quality control. Now, another thing that we can do is to take this surface that we developed in CARLSON Civil or Survey, and we can send it out as an IFC file. And of course, we went ahead and did that. I'm going to select my tin right now. And if I say open, it wants to generate the new IFC file. So I already did that, and there's no fancy tricks here. I just said open, gave it a name, that's all. So what I'd like to do now is to leave CARLSON, and we're going to go into the Navisworks, which is the BIM software. And I'll go to the big boy, Navisworks Manage. And this is the expensive one. They have 3 versions of it. They have a viewer and an intermediate, and then they have the pro version. So it depends how heavy people are getting into it as to which one I guess they invest in. Navisworks obviously is an Autodesk product, but what it really is, in a nutshell, is a collaboration tool. It can take data from almost anywhere and analyze it. And here we are in a blank BIM model, and I'm going to go ahead and open up our building. And so there's the building, and let's go ahead and just rotate it so you can see it. That's the same building we saw a moment ago. And let's go ahead and merge in the the CARLSON surface, and there it is. So now the BIM model can see everything that we just saw in CARLSON, with maybe one difference being that with the Navisworks, we can actually go in the building and we can penetrate walls and we can see what's inside. See that? We can look down the halls, we can look at windows, doors, we can walk up and down the steps. There you go, you can see some of the windows in 3 dimensions, right? Inside, outside, all that good stuff. And so again, I'm looking at the integrity of my, my data. I want to make sure that my utilities match up to the tap-in point on the building, and that would agree with whatever I've designed in the CARLSON Hydro software or the terrain model. We can look for clashes and things like that. So one additional thing we'll do, let's go ahead and bring in the rest of the project and show you how this all lines up together.
Harry, can I ask one question?
Yes.
Someone wrote, maybe I am missing something. Why did the building come in on the edge and not internal to the site?
Well, that's where the building was designed. Yeah, the only part of this project was the front of the building. The design scope of work was for the front of the building, not the back. Okay, so here's the rest of the facility. And you can see it's a very large facility. If I jump over to CARLSON, I'll give you an idea of what this facility looks like. Not that one. This is what that facility really is. It's the largest privately developed piece of land in the United States of America. It's in Alabama, believe it or not. And so that's what this BIM was. And the idea was that the contractor had to use BIM, and they had to find their own conflicts before any blades touched the ground. And so what the client is trying to do is eliminate change orders. Because if the contractor does not use BIM to find their conflicts before they go to construction, they will eat the change orders. So this is a massive change occurring in our industry right now where they're trying to get rid of change orders. And of course, you know how lucrative they can be. So some clients now are getting into BIM. This is a huge complex with many, many buildings on it. You can kind of see how many buildings are in here, right? And the idea then would be to look at clashes and things like that. So by running some tests, you can find out what utilities are clashing, which ones are not. And again, I'll show you what the output would look like. It would be something like this, where every one of those clashes that you just saw me looking at, they will identify those graphically for the client or for whomever is doing the BIM analysis. You see that? It's finding every single conflict and clash that could be occurring in the file in 3 dimensions. And you can also go by classification. So you could just look at water lines, or you could just look at water and sanitary and electric all passing through a conduit. So this is what the BIM is allowing us to do now. And you can kind of see here that I have the entire facility, including our new design of the building from Revit and the surface from CARLSON software. I would then go ahead and inspect my clashes, rectify them, run it until it has no more clashes, and if that's the case, I would then go to construction. So very, very simply and in a nutshell, that's what the BIM is for. It's for quality control. You see there's a dastardly venue behind it. Clients are trying to eliminate change orders, and in fact, this was published in Site Prep magazine, and I put contract language in the article, and that's very clear. That's what they're trying to do. But contractors now, many of them have to have BIM experts on staff, and CARLSON's data can now flow directly into that BIM system for that analysis. So kudos to CARLSON. They're right on target with adding BIM tools to the industry. Not only do architects use BIM now, but please note that contractors are being forced to use it as well because they want to eliminate change orders. So Jim, I just wanted to give you a quick overview on that aspect of it. Any questions?
There were a few more. We'll answer them after the webinar. They were we can email them directly.
Yeah. Okay, well that's it. CARLSON's menus are very simple. You can import these IFC files from Revit or wherever they're produced. You can do your own analysis in CARLSON software, and then you can also take your surface data and other data. We're not just limited to surface data. We can take other data from CARLSON, like storm sewers and utilities and water lines, and we can send them into Navisworks as well for clash detection and this whole idea. So CARLSON's right on target with 2014 CADnet and the BIM capabilities. That's
Okay, thank you, Harry. I'm going to move back over to Jim.
Thank you.
Okay, I'm back, and I want to thank Harry for showing Navisworks and how we were able to bring from CARLSON's CADnet menu an IFC file from the BIM dropdown, and I'll just show it here, and that was up here, export surface architecture IFC file. And as Harry pointed out, that's not just a TIN file or surface file. It can also be the storm and the storm network or the sewer network or water network, whatever you have designed and drawn in 3D, you can send over to Navisworks to do the clash detection. So that pretty much ends my CADnet webinar. I just want to go through the last slides and do a review on this slide. CADnet is a new module, only works in 2014. CADnet creates CAD from non-CAD sources. So one of the questions was, you know, if you get a PDF file that you can convert to line work and use that, that would be greatly beneficial over redigitizing everything. But the fact is that for bidding purposes especially, most contractors will only get PDF files from engineering and surveying houses or firms, and essentially they have to redigitize everything to do their bidding. Now, once they do get the bid, then they get the drawings. But even as in the case of that pond that I digitized, that pond came in not as a change order, but it came, the end user that I spoke to had the final contours, but they had those temporary ponds, and the only drawing that they got, or they didn't get a drawing, they got a PDF file, so they had to actually digitize those in, and they used both the CARLSON Takeoff to do the bidding estimate, and they created machine control files for their Trimble machine control to upload and create a TTM file for machine control. So CADnet creates CAD from non-CAD sources. Obviously, we can still do paper plans the traditional way using digitizers. I think everybody pretty much is doing heads-up digitizing on screen. Just instead of using a digitizer, they just get the PDF files. It allows you to zoom in a lot tighter and digitize. The raster images from the PDF import or import PDF are converted to raster images. I use PNG files. They're the smallest. TIFF are small too, but PNG I think are the smallest. And Harry showed CARLSON to BIM, and that just so if anybody wants to go to this website here, this is an explanation of the IFC standard. That is a BIM standard that Navisworks can read. Both Autodesk, CARLSON, and Revit, those products, make an IFC file that can then be imported into Navisworks. So CADnet is a brand new module released in 2013 of July with our CARLSON Civil Suite 2014 or Construction or Takeoff R6 release. And just for those that are on maintenance, just so you know this, the 2014 new modules for Takeoff and or Construction in AutoCAD or IntelliCAD, if you are a Takeoff user, you automatically, if you renew your maintenance for 2014, you get Construction, Geotech, Trenching, and CADnet menus. If you're a Construction, CARLSON Construction user, you get Construction and CADnet. So at this point, that's the end of my webinar, and if there's any additional questions, I'll try to answer them. And I do want to point out that Todd Carlson is the takeoff expert at CARLSON Software. He's up in Boston, and you can email him at tcarlson or you can call up Boston at 617-393-2300 if you have any support questions. If you're interested in purchasing or renewing your maintenance, just contact CARLSON Software in Maysville at the 800-989-5028 phone number, and we'll obviously work with you. So, Karen, is there any additional questions?
I think that we'll just answer them separately at the end of the webinar, because we're running over time a bit. So, thank you to everyone, and this will be recorded and posted online within 24 hours.
Thank you.